know now. Our next speaker is Dr. Brett Ramirez, Assistant Professor, Ag Biosystems Engineering, Iowa State University. Brett is a Illinois native, calling Crystal Lake his hometown. He attended the University of Illinois at Urbana-Champaign.
Yep, should be good. Okay, thanks, Tom. Oh, all right. So I take it everybody here got sick of ASF and needed a little change, right? Maybe. So today it might be a little bit different than most other ventilation talks, but this is going to kind of go through kind of different, really boiled down to the caretaker level, not so much at the higher level, but boots on the ground, person doing chores, try to get through what kind of that training philosophy and what is that critical information that those caretakers need to know. Basically, here's my talk. Just, if it ain't broke, don't fix it, right? If the fan's running, let it run. Don't mess with it. You got to measure stuff, right? If you don't measure, you have no idea what's going on. If something is broke, fix it. It's that simple, right? Don't keep idling on if stuff's broken, right? Get it fixed. Get it taken care of right away. And then kind of lastly, and this is where it gets real complicated, if you think it's broke, figure out what's wrong, and then make sure it gets fixed correctly, right? So if you're in the barn and you're just kind of standing there, you're like, well, I can't quite tell what's wrong. I don't know. It might be this. It might be that. Well, get on the phone or message, whatever, and figure out, get the right people involved to really figure out what's going on. So this is what I'm really going to focus right here. This is for growers. So I say caretakers, people doing chores, people in the barn every day, and we're going to look specifically at practical solutions for the day-to-day problems that are in the barn. Sometimes there are day-to-day problems, and sometimes we never notice a problem for the 20-some-odd years the barn's in place. So first we're going to really start with on how to identify the problem. This is oftentimes a little bit complicated, but then again can be pretty easy. It's pretty obvious to know if your fan's not working. It could just be switched off at the wall, or it literally is broken. But sometimes those are hard problems to identify, and so this is going to aim to kind of go through a little bit of the more complicated problems and how to solve them. And then the next part we're going to get into is figuring out what are the solutions. Sometimes it is just replacing something, but then sometimes there's kind of more complicated, bigger picture things that are going to take a little more troubleshooting, getting a few people involved to figure out what's wrong. So why does ventilation in an indoor environment matter? It is probably one of the most critical aspects. It's usually never the sole problem of the system, but it affects just about everything. Thermal comfort, right? Health, so it's not going to probably cause pigs to get sick, but it's definitely going to make it worse, and it could also be used to make it better. It could be a stress, as it gets, what are we going to hit a heat index about 105 down here in Ames this upcoming weekend? That environmental stress is going to, it's a stress that becomes a welfare concern, and it's going to, it's something we want to avoid. It also affects the people in the barn. So the caretaker itself's in the barn, and if it's a bad environment, it's going to be miserable for them. So all the more important to make sure the ventilation is doing what it's supposed to do. And most importantly for growers is, it's economics, right? It's propane, it's electricity, it also coming back to the productivity, but it's about economics. So it pays to have that ventilation system working correctly and doing what it's supposed to be doing. So ventilation, what does it look like for most people? It's usually about this word cloud, right? It is just a massive jumble of words that we have heard. We don't know exactly what they always mean, but they're there. They do something for something that we need to make sure they're doing it correctly. But this is kind of the big ones. I just stole this off an article and just put it in. This is what shakes out if you read a ventilation article. Not shockingly, ventilation's the biggest word in the article. But a lot of CFMs, pressures, insulation, pig, fan, heat, rate, exchange, facility, gas, shutter, cold barn, static. So it's just a big jumbled mess, and that's really what happens in a lot of people's minds. So what we want to do is kind of clear this up, get simple, accurate definitions for these words so that people understand. So I'm going to kind of introduce the 6 R's of ventilation success. So this is kind of the process that I see as a methodology to make sure that the ventilation runs smoothly and our problems get fixed with the right solutions. So the first one, if anybody could guess, is recognize, right? You got to be able to recognize the problem. That's where the training comes in. That's where coming to things like this, talking to your managers, territory managers, going to the trainings, understanding, taking notes, and really being able to recognize those problems when they come about. Anybody guess what the next part is? Guess? Record, right? Record. You got to make a note of it, right? If nobody knows or if it never gets written down, how's it ever going to get fixed? So record, write it down, make sure we take notes. Next one, even though it's a old school telephone, report. You got to tell somebody. Somebody's got to find out. If you're not the one in charge of fixing it, how's it going to get fixed? Make sure you get on the horn, call somebody, and report that issue. Next one is resolve. So with resolve, this is actually kind of making sure it gets done. If it's one of those more complicated problems, it has to get resolved correctly, a timely manner, and figure out really what's the key underlying problem and not putting Band-Aids on something that's much bigger. Repair, get it done correctly, and then lastly is reward. So going back to what all the environment impacts, so productivity, stress, welfare, economics, that's where the reward comes in. It's a big system that ventilation affects all of it. So by getting the process in place to make sure that the ventilation is working correctly, we can really reap the rewards in the system. So let's go through the first part. Recognize. This is our critical first step. This is the one that requires our training and experience. If you see on the slide, does anybody recognize any issues? Yeah, see some problems? So, let's go through any problem where these are located. They look like a good spot. What's coming? What happens when that brooder's on? Where's all the heat going? Right up to those backup thermostats. So what they probably have done is probably adjusted them for that fact. But again, it's still, you got to see that that's a problem, not wondering why everything's being triggered. Problem here, are cones important? Do we need cones on fans? Yes, right? There's a big efficiency difference if those cones are off. Problem where that temp sensor is located, is that a good spot for it? I think Jay uses is electrician run out of wire? Maybe. But that's not a good spot. Problem here, where's that feed line going? Right through a cool cell. Curtain sagging, are these the right soffits? So if you don't know, you got to pay attention, look, and so basically on the soffits there's just not enough open area to let air up into the attic. But so you got to have the training and the understanding of what is supposed to be done to recognize some of these problems. So it's really starting with here. So use Dory here as the example is, lost in the sea, and if you walk into the barn and you are lost in the sea of ventilation, just like that word cloud, you got to really know what you're doing. You got to put yourself in the surroundings. So if you're thinking about if I need 8,000 feet per minute on my ceiling inlet and the inlet shut because you're in full tunnel, you're off a season, right? You got to make sure you're in summer, in the right season. How big are my pigs? What's supposed to be doing? So if you don't have the concept of what my ventilation should be doing, how are you going to know if there's something wrong with it? So it's coming together and kind of putting together what you should be doing. So found this quote, you don't know what you don't know. So that's where if you really don't know, have something or someone or something that does know. So checklists, standard operating procedures are good ways to just have something in the barn, like accessible, that you can use, take with you, walk down the barn, pay attention to ventilation. I said there might be an app. I don't know if there's a ventilation app yet. Maybe I need to make one. It'd be kind of neat. Just have something to help guide that troubleshooting, something that at least gets you pointed in the right direction quicker, so you can start working on those issues sooner. Those checklists are great. They really help get the season started. They help get through the season, help keep things running smoothly. And kind of on the flip side, don't ignore ventilation, right? My barn's been running great for 2 years, so must going to run great for the next 15. So you can't get comfortable with it. It does require the constant checking. You got to pay attention to it, notice when there's something wrong, and to just not take it for granted that it's doing what it's supposed to be doing, because it might not be. So to start, this is kind of the very high-level approach to ventilation of what does it do, what should it do in winter. We have one major goal: remove extra moisture and noxious gases from the barn, generated from pigs, manure, and any combustion from unvented heaters. That's our goal for winter. You get that in your head, use that to start guiding any winter troubleshooting. Opposite, like today, summer, Our goal is generally to remove heat generated by the pigs to maintain a somewhat comfortable indoor temperature, and then we're also going to probably provide some elevated airspeed for cooling, depending on how the ventilation is. So if you look at kind of ventilation and how it kind of goes through the different fan stages, we'll just take this as the rate. As that temperature goes up, we generally ventilate here for moisture. It's usually too expensive to ventilate for gases, and then as it gets warmer, we switch over and we start ventilating for temperature. Just kind of the overall view. So the other thing is just separating out kind of the difference between using the design and operation. So we use our ventilation graph to size our fans and our number. We're after here to make sure we get everything in place so that when the seasons do come, we have the right amount of capacity to handle those seasons and get the exchange rate we need. Versus an operation, we're really looking at using the pigs, measurements in the barn to make sure we're doing the ventilation that we need. And we can make adjustments to the ventilation system depending on what we find in the barn. So, start with the very basic sensor, right? People are pretty easy sensors. It doesn't take any fancy technology. There's a lot of good that can come from just learning and the experience of training of just using your 5 senses. Well, I got taste on there, but I don't know if I'd recommend licking anything in the barn, and I can't figure out how that relates back to ventilation. But the other ones like sight, touch, smell, and sound can all be very useful tools to troubleshoot ventilation and figure out what's going on. So sight, real simply, just look at the pigs. They're a great sensor, and that's where with a lot of technology is, we're trying to extract that information right out of the pig to help make our informed decision. So as we don't have it yet, we still have our eyes that as we go through the barn, which is maybe only once or twice a day, but we can still use that information quite valuably. So things like asking yourself, where's the dunging area? Is it in a normal spot? Has it changed? Trying to figure out what is their behavior, right? So in times like this, looking at respiration rate, vices, seeing if they're huddling or probably separating out now because they're getting too warm. So if you kind of just look at in a chilled, just behavior alone can say a lot. So in a chilled situation here, they're going to start piling, right? Pretty simple to tell that there's drafts, they're too cold, versus here and they're too warm, they're trying to spread out. You can see pretty nicely where the brooder's at. Versus when they're comfortable, they're all kind of nice, evenly spaced, kind of in that nice touching, not too close, not too far setup. So we know too cold or too hot or comfortable? Too cold, right? What about this one? Too hot, right? So just simple, just recognizing the pictures, and when you're looking at the pigs, being able to tell what their comfort is. Go back to my slide. So equipment. So also use your eyes to inspect the equipment. Are the shutters dirty? Is there any obvious issues? Can you see motors out of alignment? Is there noticeable tears, holes, gaps anywhere? Just taking an inspection of ventilation equipment and the pigs rather than just doing the chores. It really takes going through with a ventilation mindset rather than just, I got to get X amount of things done and not pay attention to the surrounding equipment. So touch, I guess you can touch the pigs to feel if they're damp or dry. Touch motors if they're warm or hot. Just use your hands when you can to be safe about it, but use that to help diagnose. Smell can be used to, does the air smell gassy? Do I notice any air quality issues? Does it all of a sudden smell a little bit more like ammonia if hopefully you're not desensitized yet? Actually tell. Same with equipment. Do you smell something burning when your fan's on? Is there too much dust? Is the belt worn? Just use kind of the different senses. Sound, listen for coughing. Are they making a lot of noise? Are they saying extra anxious than normal? Same with equipment, grinding noises, just very simple things, but just knowing it and attributing it more to ventilation than all the other things that are going on in the barn. So the next step, record. I don't have too much here, just make a note. Be kind of interesting if they get into more electronic management, maybe. Just finding ways to track repairs, maintenance requests, etc. Of ways, and you can actually start to figure out timelines, how long it takes to get fixed, how long are the pigs possibly not getting the best environment possible if that maintenance isn't recorded. Report, the right person must know the problem exists. You're telling your mom it's not going to get it fixed, right? You got to tell the person who's going to be able to put in the right request, get in the barn, get the equipment ordered, and get things fixed. It really then moves the process forward and gets the ball rolling. So resolve, this one a little bit trickier, may or may not be needed. If something just broke, fix it. But if it's something like just can't get the right airspeed at my inlet during the winter, could be a whole host of other problems: fans, dirty fans, inadequate soffit area, etc. So that's usually when you might have to call in some other people. It's going to take some troubleshooting, might take some measurements. It's going to get a few brains involved to figure out what's really going wrong and where we can start to fix the system or help improve it. Repair, get it fixed and get it fixed correctly, so not just swapping out for the cheapest motor, making sure it's the right motor that goes in. So if it was brand X, it would X horsepower, make sure that's the right one that goes back in. Or make sure you adjust your motor curve too when you do it. But paying attention to the repairs and making sure they're going in correctly. So just using the proper techniques and making sure the right things get maintained well is critical. Like I said, everybody gets the benefits. It kind of goes back to ventilation, touches all aspects of the pigs in the house, from environment, productivity, health, energy usage, welfare, economics, and comfort. It's really hard to put a monetary value on how much does a good ventilation system get me. But I think we know how much a bad ventilation system does. So it's just important to make sure things keep moving smoothly. All right, so now we're going to focus a little bit more on specific examples of recognizing and resolving, because these are probably the two main ones that are that we can use every day and actually get some things fixed or improved if we notice we're having problems. So I'm going to just stick with mild to hot weather. I'm not going to get into cold weather since it's muggy and horrible outside. Here's kind of the main categories if I'm trying to take a look at troubleshooting and improving ventilation. I'm going to focus on these kind of key categories: building envelope, fans, soffits, inlets, curtains, cooling pad, my control settings, and then environment inside the barn. So what is the actual environment and what are the pigs doing? So these are kind of the categories that would drive my troubleshooting and where my focus areas are going to start. And so that's why I want to focus on kind of each of these and kind of go through some scenarios to figure out what's critical. So let's just start with a perfect example. My room is just too warm. Just very basic. It's just too warm. It's, maybe it's 90 outside, but my room's 100. Well, hopefully not, but extreme example. What is the outside? If it's really hot outside, your room's also going to be really hot unless you have like a cool cell or something else for cooling. So sometimes it's not uncommon for rooms to be. We usually hope that we keep them no more than about 4 Fahrenheit above outside. So they usually use that as a guide. Is there wind if you're in a natural barn? What's the air exchange? Going into the controller, do you have the right pig weight in? If you're off by a couple hundred pounds, it's going to really change the set point. Are the temp sensors accurate and clean? Are they caked with dust and are reading off? Have they been calibrated recently? Is there any other nuances? You use the wrong brand? Are they in the right spot? If you have multiple in the room, are they all different? Do they within a reasonable amount, or are they similar? So curtains, generally, let's assume tunnel barn or a natural barn. What are the air speeds at the curtain? What's the rope quality? Is it stretched? Is it fraying? Does it need to be replaced? Or is there any other issues with the curtain? The other one is just fans. Can't harp on fans enough, as they're really the primary driver of ventilation. Dirty shutters, they can reduce airflow by about 20%, so just keep them clean. Wash them when they power wash, keep them dust free. As those things get weighed down, they just cannot move as much air. Especially in times like this, I think extra 10% on a really hot day can really help some pigs. Belt tensions, make sure they're keeping tight, motor curves, alignments, pulley wear, etc. There's multiple things, but you got to know that these are things I need to check. So again, having that checklist, having that guide, that's a lot of things to remember if you walk into a barn. So having something tangible and physical with you can really help guide some of this troubleshooting. So as always, just got to harp on static pressure and what it means for the ventilation system. It's the primary driver. Our fans pull air out of the building to create a negative pressure, and that's what drives air into the barn. So as pressure goes up, fan flow rate goes down. It's pretty simple, but that's what, if your building's too choked, if you do the door slam test and that door slams, your pressure's too high, you're probably not getting enough exchange leading to a warmer room. But simply is that. Going into shutters, here's just some pictures I took when I was cleaning shutters one day. Just kind of looking at just how much this is a really bad case, but it illustrates the point. Probably hadn't been cleaned, but dirty shutter, moderately cleaned and clean. You can just tell the difference in the opening and just how much extra weight some wet, dirty dirt just sits on those shutters and weighs them down. They took those off, and it just made a world of difference in the room. So you can take a little bit smaller fan here, just see the difference in how much they're open and how much air they're moving. So again, going back into warm, temperature rise versus tunnel airspeed. Our target is about just shy of 4 degrees Fahrenheit down the length of the barn. So if you have different air speeds in the cross section, that's going to change how much heat can accumulate inside the room. So for example, on this one, maybe like, I want really, really windy at 1,000 feet per minute. You definitely beat the target, but the amount of fans and the amount of static pressure it takes to achieve that is just unrealistic. Versus down here at 200 feet per minute, it hits the target, but the barn length is somewhat limited. So usually we're in the recommendation of the 350-ish range that kind of gets you your normal tunnel finisher right in that 200-foot mark, and it keeps the temperature rise at a reasonable amount. Another one, so kind of going into effective, kind of how do pigs perceive temperature, right? It's a combination of all the different environmental variables. It's humidity, airspeed, temperature, and the radiant surfaces. So here I kind of just gave an example of I'm just arbitrarily calling comfortable, cool, warm, hot. No data on that one. And so I just kind of equated room temperature and kind of your different tunnel stages. And so essentially, as the temperature goes up, we have more stages kicking up. And so generally, if we're starting with ceiling inlets and then moving over the tunnel curtain, the amount of actual airspeed inside the room is not changing a whole lot. So it's kind of slowly going up. And then basically as that temperature hits right around that skin temperature of the pig, they're going to start getting warmer, right? If the surrounding temperature is greater than the pig temperature, heat actually starts to move into the pig, right? We always have to have a gradient from the pig temperature to the air temperature, or else we start going the wrong direction. So when it's 100 degrees outside or 95 this weekend, that we have to do something extra because it's warmer than the pig, and you're going to be driving heat the other way. So that's why we use sprinklers and other cooling methods to help keep the pigs cool. So kind of change it up. So let's go to now more like a transition phase. So maybe there's some dead spots as we're switching over from tunnel to or inlets to tunnel. So kind of key things to focus on here would be inlets, infiltration, soffits, curtain, and controller. Inlets, what is the airspeed? Are you out there with your Kestrel making the measurements you need to figure out what's my airspeed? Am I in that recommended range of about 800 to 1,000? But you actually got to make the measurement. You can't just put your hand up there and feel. You got to have something quantitative. As the opening need adjustment are my settings correct in my opening? In my openings, infiltration. How well is my barn sealed? If we're pulling air through the gaps, it's not going through my inlet. That might be one reason. Are there noticeable gaps that can just be easily sealed up? Are just doors left open? Is there holes? Just simple things that just to do to keep air going through the inlets. Looking at airspeed at the curtain. So as that curtain opens, is it following the correct airspeed? Is it too high, too low? What's the opening speed? Are we opening it too quick, too slow? But things to pay attention. So a little bit harder if you're sitting there and just watching a curtain. It's probably like watching grass grow. So it might help to have some data or doing some longer term measurements. So curtain, what are the settings? Is it calibrated? Are we off at the opening, start, and end? Just things that go punch through the controller. So the importance of fresh air distribution, we want to avoid dead spots or cold spots throughout the room. We want to make sure we're getting good mixing inside the room and we're really getting the fresh air delivered to where it needs to go. So proper placement and operation of ceiling inlets is critical, and we have to use static pressure to make sure we distribute that air correctly through the inlets. So static pressure, now we're not talking across the fan, but across the inlet here. As that no static pressure across that inlet, that air jet just drops, especially when it's really cold outside. Versus when we have enough static pressure, we can keep that 800 to 1,000 feet per minute at the inlet and get the nice jet mixing that we desire. So for a sufficient jet mixing kind of looks like this. I know this isn't a nice, clean, perfect environment, but that's really what we're shooting for. That's what that 800 to 1,000 feet per minute at the inlet generates. And gives us that good mixed well room. Insufficient, Cold air drops, and we get secondary rotary mixing there, which is just that stale air that as you kind of walk across the pens, you start to see is like, oh, well, this was really nice, and then you can tell how stale it gets as you get closer to the wall. So versus in summer, the other thing we got to think about is if static pressure increases across the room, as I mentioned before, fan capacity goes down, and we're losing our CFMs. So I'll switch over to cool cells just in case there's some people with sow farms, and just to kind of briefly chat about it. Weather, what's the outside temperature and humidity or dew point? Especially with some coming up on this weekend, I think it's probably going to be like 90. I think heat index at 105, so I think that's 95 and like 80% RH or something. Your probably cool cell's not going to be doing a whole lot if you're here in Central Iowa. That's probably one of the ones to consider if you want to operate it or not this weekend. The controller, what's the on temp for that cool cell? Are those temp sensors accurate? Where are you measuring that to make the decision to turn on the cool cell? Are they in good locations? Are they reasonable? Again, it goes back to calibration, cleanliness, placement, making sure that your sensors are in the right spot. Pad, streaking, is it getting water distribution? Are holes plugged? Is the pump working? Is the pump clean? Has anybody looked at the strainer? What's my water pressure? Is it too high, too low? A lot more questions comes in if you have a cool cell, because you got to put cool cell plus everything else I just talked about. So it really adds another level. But again, to keep things working smoothly, you got to have all these things incorporated. And fans are the same as if you were in any other type of barn. They just got to make sure clean, belt tight, cones working, voltages correct, and making sure things are right. So here's just an example of an old pad and a new pad. It's just so scaled, and there's so much debris and stuff that's accumulated. It's just so restrictive, you can't pull much air through, versus a nice clean pad being able to really move some air. So kind of with that, I think just wrap it up with the key take-home points here. The key is really gaining the experiences and starting the training to really develop the better recognition. If you don't have the recognition, then the barn's perfect, right? So until you notice something, that's where everything starts. Or if you're too well trained, then you notice everything, and then you're kind of burning yourself. Go through the checklists. They are important. They've been really perfected over the years by a lot of people. They have some good stuff that you just got to have with you. Not try to remember like, oh, I saw that in a presentation a few years ago. Have it there with you. You can print them out and just have them. Perform routine maintenance. This is another just critical one. Just do the stuff every day that needs to be done. Don't put it off. Don't wait till the last minute to do something. Make sure things are done in a timely manner and things are kept maintained. Then going back to that, just the whole big sphere of ventilation and things. There's all these things to do, especially if you're a caretaker. I kind of set aside a little bit of time for ventilation and kind of take one pass through the barn is focusing on just that to make sure you're getting what you need and it's doing what it's supposed to do. And always use the pigs to help guide your feedback. So kind of with that, take any questions? Great.
Any recommendation for today's faster growing pig on a CFM per head?
More than what it was years ago.
Okay.
More than what it was in Midwest Plant Service 1985. I don't know, what's the current one, like 110 or something on a tunnel barn? 110, 120?
I don't know if it's, I've been finishing?
Yeah.
120.
120?
120. That's not tunnel. Right.
Yeah.
Tunnel. Okay.
Tunnel, it'll turn out to be more like 200, 250 CFM a pig, depending on barn dimensions.
Do those recommendations change when you go to positive ventilation instead of negative? For a CFM for animal?
Do you have with a cool cell or without?
Most of them are with, I would guess.
Yeah. So right, it's a balance. We're trying to we're balancing comfort with exchange, right? We use exchange to move the heat out, and we're using comfort as localized temperature, humidity, and airspeed. So it depends, right? It depends what systems, how that air is distributed on the pig, stocking density, Mainly those. So generally speaking, it depends really is what you're trying to do. So with the 200 for tunnel, you're balancing heat accumulation and airspeed at that point. It's kind of it's the balance point between the two. You go under, you're going to have less airspeed and less exchange. You go over, you get more. So it's kind of you got to keep the comfort and exchange rate kind of separated in your head to do depending on what your goal is. Usually we want to do exchange first, and then there's other ways to do comfort. We can use stir fans, sprinklers, etc. to manipulate that local environment for the pig. Anything else?
Any other questions, Brett?
Yeah, one other. Is there any work anywhere on the effects of carbon monoxide on wean pigs?
I think there's some anecdotal company work that somebody shared with me, but I don't know if there's any scientific research on it.
I have situations where my people wear a monitor and I'll have levels that rise because of whatever's going on, but I never see a visual effect on the pigs.
Yeah, and it's a challenging one, right? So that's a question, I always ask myself is what is the impact of the high, CO2 as well, ammonia that usually happens on our 2 CFM per head in middle of winter, and where do you balance CFM versus LP? But pigs still do great, right? That's kind of the challenge there is you don't usually see an effect, right? And maybe it's really small, but what does that across the system really equate to? But
you're not aware of any work that's been done on that particularly?
Not to my knowledge.
Okay.
They tend to do more of the gas work for like poultry, just because their concentrations tend to be a lot higher than what we see in pigs, where they do really specific preference testing for, they'll have a bunch of chambers at different concentrations and put chickens to see where they go and look at production and stuff, but we don't see it too often on pigs. Doesn't mean we can't start.
We're a little ahead of schedule, so if anybody has any more questions, otherwise we'll let Brett. Well, thank you for attending, and